All right, guys, let's start with question 31. Find the intervals on which the function is increasing, decreasing, and the local extrema. We are given function f of x equals x to the fourth power plus 4x cubed plus 35. Let's start by graphing. So we have x to the fourth power plus 4x cubed plus 35. The graph. I'm going to adjust the window to y minimum 0 and make our y x min -10, max 10. Let's graph that again. There we go. All right, so we can see that we do have a minimum here. So let's go ahead and find that. So second trace, number 3, scroll slightly to the left of the minimum, hit enter. Scroll slightly to the right of the minimum, hit enter a third time. Our minimum is at -3, 8. Like that's 3.9999. That's 3. Okay. All right, we can answer all of our questions. So quick sketch looks something like that, right? -2, -1. So that's -3. So the function is increasing. From -3 to infinity. All right, and then the function is decreasing from -infinity to -3. And the function has a local minimum at f -3 equals 8. All right, so pretty straightforward with just a little bit of graphing. All right, next, 32. Oop. F of x equals x raised to the 16th power plus 7x squared. So again, I'm going to graph this. We're all about test taking techniques for the final right now. Okay, plus 7x squared. Graph that. Window, let's see. I'll make this a -5. -5, 5, graph that. All right. So we can see that this is a parabola, right? And so we're going to sketch this really quickly. All right, so for what intervals of x is the graph concave upward? So it's concave upward from -infinity to infinity. There are no inflection points here, okay? Okay, next part, for what intervals of the graph of x is the graph concave downward? It's not concave downward, so the graph is never concave downward. And see, I misstated that. This is just concave. All right, determine the x-coordinates of any inflection points of the graph. We didn't go from concave upward to concave downward, back to concave upward. So there are no points, no inflection points. No inflection points. no concave down. All right, 32 done. 33, what do we got? Oof, we're gonna need a new piece of paper. Okay, 33. Let's graph this. So we have 3x times x minus 2 raised to the third power. Let's graph. Let's make this a little bit bigger, change our window to maybe 10. There we go. So we can see that we do have a minimum there. I want to change this -2 maybe. All right, perfect. So that's what our graph looks like. Let's do a quick sketch. Let's write f of x equals 3x, x minus 2 cubed. Right here, here, here. All right, so this is gonna look something like, want to go through this origin. There we go. Something like that, right? Good enough. It's not beautiful. It's just, it's good enough. Okay. So let's see, what is the domain of the function? So there's nothing disrupting this function. There's nothing in the denominator. There's no crazy like factors. So the domain is -infinity to infinity. All right. What is the y-intercept? So we're going to do some quick calculator work. So second trace value when x is 0, enter y equals 0. So y-intercept equals 0. Sorry. This isn't grammar class for right now. This is just math. All right. So now we're doing x-intercepts. So obviously when x equals 0. So now we want x-intercepts. And that's when y equals 0. So we already know when y is 0, x is 0. So that's one of our x-intercepts. X equals 0. And then we can see clearly that we have another x-intercept over here. So I'm just going to go back to my y equals, hit enter, y equals 3 equals 0. Sorry, tongue-tied. Hit enter. Now I'm going to do second trace 5. I'm going to hit enter. Then I'm going to hit enter again and enter a third time. And this is telling me y equals 0, the x equals 2. So that's my other point of intersection. So x equals 0, comma 2. All right, what are the local maxima? We do not have a local maxima. Then the next question here is, what is the local minima? Here's our minimum. So we're going to do some calculator work. Second trace 3. You guys should already know this. We're going to scroll slightly to the left of the minimum, scroll slightly right of the minimum, hit enter, and that x is 0.5. So x is 0.5, I need to slow down, sorry. 0.5 comma -5. But this is 0.5, this is 1, and this is 2. All right. The local minimum right here is at x equals 1/2 or 0.5. It'll accept either answer. Okie dokie. So the next thing we're asked for is the inflection points. So for this one, we want to find the second derivative. All right. Here's where we start doing some more business calculus work. So f of x, right? So f prime of x is going to be 3x times 3x minus 2 squared plus 3x minus 2 cubed. I'm going to do some algebra work, and first I'm going to pull out the x minus 2 squared term from here and here. So that's going to leave me with x minus 2 squared, 9x plus 3 times x minus 2. I'm going to distribute and then collect like terms. That's going to give you x minus 2 squared times 12x minus 6. Okay, so now that's my f prime. Okay, good. So now I'm going to take the derivative again to find the f double prime. All right, and that's going to give me, this is where it gets long, product rule, friends, okay? So 2 times x minus 2 times, so 2 from the power, right? 2, bring it to the front, and then also multiply by the derivative of everything inside, which is just a 1 times, keeping the second term, 12x minus 6, plus, keep the first term, x minus 2 squared, times the derivative of the second term, which is going to be just 12. Okay, now we're going to factor out 1x minus 2 term. So x minus 2, that leaves me with 2 times 12x minus 6, 2 times 1, that's a 2, 12x minus 6, plus I factored out one of these terms, I still have 1 left, times 12. Now I'm going to distribute everything in here and combine like terms. That's going to give me x minus 2, 24x minus 12, plus 12x minus 24. And that's going to end up giving me x minus 2, 36x minus 36, f prime. And now I'm going to set each of these factors equal to 0. So x minus 2 equal to 0 means x equals 2. And 36x minus 36 equal to 0 means 36x equals 36. I'm just showing you guys for notes. All right, so those are your two inflection points, x equals 1 and x equals 2. This is going to give you your inflection points. Okay, so that's this part right here. On what interval is f increasing or decreasing? Okay, so again, going back to your graph, from here, negative infinity to 0.5, negative infinity 0.5, this is decreasing, right? Okay, then, from 0.5 to infinity, this is increasing. All right. Now, on what intervals is f concave upward or concave downward? So here's where your inflection points matter, okay? So let's take another color. Okay, so your inflection points are at 1 and at 2. Okay, so here for this portion, you can see that this is concave upward. This is concave downward. And then it's concave upward again. Okay, so let's put that into interval notation. So it's concave upward from negative infinity to 1. It's concave, so concave up, concave down from 1 to 2, and concave up from 2 to infinity. All right, so I think that's a good way. You can maybe give yourself some notes and maybe maintain some of your credit if you do concave up, concave down, up, and show how you're getting your results. Okay, and then the last part is identifying the correct graph. So you won't see these until the very end. If you have them on the final exam, they'll pop up, but we already have our graph, so we know C is out, D is out, A is upside down, so B is our correct answer choice for the graph. All right, great. Let's go to question 34. Okay, we're interpreting this graph. Let's make this a little bit bigger. Okay, so we want to evaluate, be careful with these, question 34. They're trying to be sneaky with these. They gave you this graph over the domain from 0 to 10, but then over here in the details, they want you to find the absolute minimum and the absolute maximum over the interval 5, 9. So we're only going to evaluate from 5 to 9. Everything outside of that, we don't care. It doesn't exist for us right now, okay? So for this first part, the absolute minimum within the domain of 5 to 9 is this point right here. And that's at x equals 7 and y equals 4. So the absolute minimum is 4 at x equals 7. So again, you can sketch this really quickly. I would do like 5, 6, 7, 8, 9. I should have graphed this kind of different, but whatever. Yeah, my graph sucks. All right. 1, 2, 3, 4, 5, 6. All right. So at 7, the graph is at 1, 2, 3, 4. And then it goes at 9. Let's see, 9, 5, 6. Okay, 9, 5, 6. All right, there we go. And at 5, let's see, 1, 2, 3, 4, 5, and 5. All right, 1, 2, 3, 4, 5. My graph looks janky. So this is y equals 6. This is 4, and this is 5. All right. My graph sucked on this one, but whatever. So from 5, this is the y is 5, 4, 6, at 9. All right, and this is just interpreting. I think you guys have been pretty good on the unit exams for this question, but just be careful right here. Like I was saying, it's in the problem statement itself. They gave you more information in the graph depiction than what you need. And it could be very easy to say, oh, here's the maximum at this point, right? And here's the minimum, but that's not what they're asking you for. They're asking you for the absolute minimum, absolute maximum within a defined interval. So pay attention to that on the test. But to start by this. Okay, 25, no, 35. All right. So f of x equals -9. Oh, no, I'm sorry. X cubed minus 9x squared plus 15x plus 6. So they gave you this function to start with, so we are going to graph that first. So x to the third minus 9x squared plus 15x plus 6, graph. Okay, and they're giving us different intervals to evaluate. So for the first one, we're evaluating from -2 to 8. So we need to change that -2 to 8, and let's make our y min -10, 10 graph. We're gonna need to get bigger here. All right, y. Let's go -20, 20. Cool. Now our y minimum we still need to change because I can't see the rest of the graph down here. So window, let's make this -50. We need more. Oh, we're gonna need a lot more. Okay, let's do -75, 75. We just want to see everything. Okay, that looks good so far. Cool. Okay. So here on the first part, let's see. Part A, the interval they want us to evaluate is from -2 to 8. So our window is already set to -2 to 8. So let's look at our graph again. Where do we see our absolute maxima? It's over here at 8. So we want to do second trace 1, x equals 8. What is that value? It's 62. Boom. We're done with this first part. All right, so now in the same interval, we want to look for the absolute minimum. We see the absolute minimum is over here, and we know that's all the way at -2. So second trace net 1, then we're going to evaluate at -2, and that gives us the y equal to -68. So the absolute minimum is -68 at x equals 2. And that was for the interval from -2 to 8. Okay, so now we're moving on to B, and that is having us evaluate the function over the interval -2 to 5. So we're going to go back into our window, and we're going to leave the -2, change the x max to 5, graph again. Okay, so now for this interval, the absolute maxima is where? Here, right? So we're going to do second trace 4, slightly to the left of the maximum, hit enter, slightly to the right of the maximum, hit enter a third time, and it tells you x equals 1, y equals 13. So the absolute maximum is 13 at x equals 1. Okay, and the absolute minimum, well, we can still see that the absolute minimum is over here at this point, and we know that point already. It's at x equals -2, and the absolute minimum is -68. Okay, so that's part B. Now part C is asking us to evaluate over the interval from 2 to 8. So we go back into our window, change our interval to 2 to 8, graph again. Okay, and so now we see our absolute maximum is over here at x equals 8, and we know that value already. So the absolute maximum is 62 at x equals 8. Now we can see here that we have a new absolute minimum within this interval. So we're going to do second, trace, minimum, slightly to the left, enter, slightly to the right, hit enter, enter again, and x equals 5, y equals -19. So the absolute minimum within the interval 2 to 8 is -19 at x equals 5. So this problem is just a lot of graph work and knowing and paying attention to the intervals that are being given in parts A, B, and C. So make sure you pay attention to that, right? This isn't a hard problem, it's just the details that are involved and making sure that you're paying attention to those details and adjusting your graph window accordingly. So your x-min and x-max should change according to the intervals that are given in parts A, B, and C. Cool. Okay, 36. Okay, a company manufactures and sells X cell phones per week. The weekly price, demand, and cost equations are given below. Okay, what price should the company charge for the phones, and how many phones should be produced to maximize the weekly revenue, and what is the maximum weekly revenue? Okay, so we know that revenue is a product of X times P. We are given our price demand function. So X times 400 minus 0.5X, which is going to give us 400X minus 0.5X squared. And then we want to maximize this. So we can do this two ways. We can do this on the calculator, or we can also take the first derivative of our revenue function. So r prime of x equals 400 minus 1x. We're going to solve for x when this is set equal to 0. We're maximizing or minimizing. In this case, we are maximizing our revenue. Okay, so 400 equals 1x, so x equals 400. That's how many units we should produce in order to maximize our revenue. And at this level of production X, what price should we be charging? So P evaluated at 400 is 400 minus 0.5 times 400, which gives us a price of $200. And another way we could do this is by graphing. You guys already know I love to graph things. All right, so 400, we're graphing the revenue function. So 400x minus 0.5x squared. I'm going to change my window. We're operating in real units, so 0 to, let's go 500. Revenue should be fairly large, so let's start at 10. I'm just going to go with 10,000. No, I think I'm going to leave a lot more. 500,000. All right. That's my revenue function. Alrighty then. Let's, why did it need to be at 500,000? Let's change this to maybe 750 and I don't know, 100,000. All right, cool. There we go. So second trace maximum for slightly to the left, slightly to the right. And there's our x. X equals 400. So we could have graphed, found our maximum x value, and then calculate the price. And that's it for part A. Okay, so then part B, what price should the company, what is the maximum weekly revenue? So if we already did the maximum, We know how many units are produced, X equals 400, and Y is your maximum revenue, which is 80,000. Or you can go back and calculate it. 400 times 400 minus 0.5 times 400 squared. And that'll give you 80,000 as well. Okay. Now part B, what price should the company charge for the phones and how many phones should be produced to maximize the weekly profit? So now they're asking us for the profit function. All right, so now we know R of X profit equals R of X minus C of X. So test strategies, right? We already have our R of X input into our Y equals. So R of X is already there. Now I just need to do minus the cost function, and it gave us the cost function. So minus parentheses, and I'm gonna put the cost function in 15,000 plus 135x, close my parentheses, and I'm gonna graph again. So now I have my profit function graph. I'm gonna do the same thing. Second trace. I want to find the maximum, number 4. We're going to go slightly to the left of the maximum, enter, slightly to the right, enter, hit enter again. And this is telling me maximize my profit. I should sell X units at 265, and my profit will be equal to 20,112.5. So test strategies, we can do it long way, but they're not asking us for the profit formula. So if I can save myself some time, I'm just going to input R of X minus C of X, let the calculator do some work for me, graph it, second trace, find my maximum. That's going to give me the units produced and the profit, right? This is my profit. Now I need to calculate my price at 265 units produced. So price is 400 minus 0.5 times 265, and that's going to give us a price of 267.50. So in order to maximize our profit, we're going to produce 265 units, which are phones in this case. We'll realize a profit of $20,112.50. And we're going to sell each of our units at a price of $267.50. Cool. And we're moving on. Okie dokie. 37. Okay, a company manufactures and sells television sets per month. Monthly cost and price demand equations are given. Find the maximum revenue. So again, revenue is X times P. They gave us our P, so X times 300 minus X over 20 equals 300X minus X squared over 20. And test strategies, we're plugging it into the graphing calculator. Okay, Y equals 300X minus X squared divided by 20. Graph. We're gonna need a lot more space on this one. Okay, X. I'm gonna go 5,000, and my Y max, I'm gonna go 500,000 on this one. Cool. All right. I can see my maximum. I don't really honestly care about what else is going on over here. This is a point I'm focusing on. So second trace, maximum, slightly to the left, enter, slightly to the right, enter, enter again. X equals 3,000. And Y equals 450,000. in revenue. That's basically 3,000, guys. Okay. So the maximum revenue, A, is 450,000. The maximum profit, okay, so now they're asking us for profit. So again, like we did before, we already have R built into our calculator. So now I just need to subtract, open parentheses, and then minus the cost function, right? So 73,000 plus 40x, close parentheses, graph again. So now this is showing my profit function. I'm going to go second trace. Number 4 maximum, slightly to the left, enter, slightly to the right, enter, enter again. Because again, they're not asking me for the actual function, they just want the result. So I'm going to maximize my time. Okay, so profit maximized gives us X units, 2,600. The maximized profits equal $265,000. And then I'm going to calculate my price point. So price equals 300 minus 2,600 over 20. And that's going to give me a price of $170. Okay. So in order to maximize my profit, I should produce 2,600 units. My maximum profit would be $265,000. And I'll sell each of these units at $170. Okay, now part C. This is A, this is B, now C. So now C is saying when each set is taxed at $5, find your maximum profit details again, okay? So what we're gonna do here is go back into our Y equals, and we're gonna go all the way to the end, and we're being taxed $5, right? So that's going to be a minus 5x, minus $5 in tax per unit X, okay? Hit graph again. Second trace, number 4, oops. Slightly to the left, enter, slightly to the right, hit enter, just go a little bit more. Okay, so profit max with a $5 tax, you should produce X units at 2,550. Your profit maximization result is $252,125. You can see that on your X and your Y. Okay, so now you just need to find out the price at this volume of units. So again, 300 minus 2,550 over 20 equals 172.5. Okay, so your profit maximization with a $5 tax imposed, you would produce 2,550 units. Your profit would equal $252,125, and you should be charging $172.50 per unit. Okay, next, 38. Oh, these are these set ones. You know, guys, I don't really like these problems. Okay, let's see. The manufacturer of hospital supplies has a uniform annual demand for 500,000 boxes of bandages. It cost, I need to get together. Okay, it cost $20 to store 1 box of bandages for 1 year and $320 to set up the plant for production. How many times a year should the company produce boxes of bandages in order to minimize total storage and setup costs. Okay. So 38. The first thing we need to do is set up our storage cost term, and that's going to be $20 to store one box, so $20. And we don't know how many units, so we take an average, so X over 2. Then we also need to have an idea of how many runs we're going to produce, which is going to impact our setup cost. So runs, we know that we're going to produce 500,000 annually divided by X. However many units are produced per run, okay? Will tell us how many runs we need total. And then finally, we have our setup cost, which is equal to $320 times the number of runs. So 500,000 over X. Okay, and so finally, our cost function is our storage cost plus our setup cost. So that's going to be 10x plus, it's a lot, plus 160 million over X. Okay. So now we have our cost function set up. Then we're going to take the first derivative, so C prime, and that's going to give us 10 minus 160 million over X squared. Now we're going to solve for X. So 10 equals, we're going to solve for X by setting this C prime equal to 0. So 10 equals 160 million over X squared. That's going to end up giving us X equals 4,000. Okay, so then we know we're going to produce 4,000 units. So then we take this information and plug it back into our runs formula. So that's going to give us runs equals 500,000 divided by 4,000. And so that's going to give us 1, 2, 3, so 125. So in order to minimize the cost, the factory should produce 125 runs a year, and each run should contain 4,000 units in production. All right, guys, that's that problem. They're not so bad. I just don't like them. Okay, the next one, 39, same concept. We have storage cost, and then we have setup cost, and we have runs. Okay, so this company, they produce 1,250,000 books over X. Their storage cost is 1 times the average in storage. Their setup cost is 250 times times 1,250,000 over X, the number of runs. Okay, so then their cost function is X over 2 plus, it's a massive number, 3, 1, 2, 5, 1, 2, 3, 4, 5 zeros. 312,500,000 over X. Okay, so the same thing, we want to take the first derivative of this function, and that is going to give us 1/2 minus 31,250,000 over X squared. And now we're going to set this formula function equal to 0 and solve for X. So that's going to give us 1/2 equals 1,312, 500 over x squared. We're going to solve for x, and x is going to equal 25,000 units. Okay, so this company, in order to minimize their cost, they should produce 25,000 books in each run to meet their annual production goal. Okay, so this one, they're asking us how many books per run. This is what they're asking. The previous question, 38, they were asking how many runs. So again, put a star by 38, put a star by 39, and just make sure you're clear on what is being asked of you. One question is asking you how many total runs per year. The other question is asking you how many units are being produced per run. Okay, so make sure you guys are clear on the differentiation between these two problems and the way they're asking you the question, okay? All right, let's move on to 40. So in question 40, we're being asked to calculate the integral over a defined space. I don't like this mumbo jumbo. Don't look at this. I don't even know if this was on y'all's homework. We've gone over how to do integrations with defined, with defined points. So we're gonna just calculate we're evaluating the integral from 4 to 9 for 7x squared dx. Okay, we know that taking the integral, that's going to give us 7x cubed over 3, and we're evaluating from 4 to 9. We're going to calculate these numbers. 7 times 9 cubed over 3 minus 7 times 4 cubed over 3 gives us 5103 over 3 minus 448 over 3, which equals 4655 over 3, and that's our final answer. Don't even look at this craziness. Like, I understand what they want y'all to do, but just do your integration rules, evaluate from the upper and lower limit, take the difference. You guys know how to do this. Don't look at that craziness over there. Okay, so that's 31 through 40. That one was pretty easy. Again, I think that was pretty quick and straightforward. So if you guys have any questions, send me an email, let me know, and good luck on your final. Bye.